Okay, so let's get started. We're going to be taking a look in this tutorial at how we can actually edit our volumetric efficiency table utilizing our closed loop Lambda data that we've already set up and configured in the last few tutorials. So let's jump in here and take a look at what we're going to be doing here and the different functionalities we have for making our adjustments within our volumetric efficiency table. Now, let's jump in here quick and let's first just review what's going on with our closed loop Lambda correction and all the adjustments we made in that last tutorial. And then we'll jump in here and talk about the actual changes we will make doing two different techniques I'm going to illustrate in this training module. So we're going to go here from our field tuning page and jump over into our closed loop Lambda. Now in here, we've went through this in that last training module. We spent about 30-40 minutes setting up both our period table and then testing our gain table. Now the period table will be the latency or the response of the sensor. This depends on where the sensor is mounted in the exhaust stream and the sensor that you're using. In this case, we've measured our period here and we've placed the proper values that we've used from our telemetry here to actually populate the values into the table. So we know at a given exhaust mass flow that a value of something like 775 milliseconds is the correct value, or at idle here in our exhaust mass flow, this is going to be somewhere between 700 milliseconds for that sensor's response or latency. So we've put our values in here. We have our gain value that's going to be how quickly it makes adjustments. 100% means it makes all of the adjustments in the closed loop correction within one cycle. 80 means it's not making all of those adjustments in one cycle. It's slowing down the response. So the period and the gain have to be sorted out, and we know we have pretty reasonable and accurate closed loop response if we tested it in that last training module. We've also set our allowable limits to begin our calibrating and tuning. So we're allowing plus or minus 25% of adjustment in our closed loop trims. And we can see here, in my case, I've zeroed out 10 to 0 kPa, full engine vacuum, essentially where I'm estimating the engine to be an overrun. I'm going to make sure that I have zero correction happening in the closed loop, so it doesn't chase any kind of inaccurate fueling on and off throttle conditions. We might even have to expand that out here to 20 kPa, but in this case, I'm going to leave it at 10 for right now until we really start to do calibrating and tuning. We've set our limits. We've set our response from the closed loop. Now let's actually jump in and take a look at what we can do in terms of adjustment. And that's going to be our quick Lambda adjustment feature, or just looking at what the closed loop correction is doing and manually making adjustments to our table. Now I'm going to demonstrate this at idle, and then I'm going to go drive it, capture some data, and we'll come back in and play back in our telemetry plot what we need to look at in order to use either function for editing our V table. So jumping back in here to our fueling, with our closed loop set, we know that we have a desired lambda aim coming from our aim table here. That's what we want to have our engine run at. Our volumetric efficiency table here represents percentage of cylinder filling. And we've entered all the information in for the volumetric efficiency airflow model to calculate correctly. So I've entered in number of cylinders, engine displacement. We have our charge temperature being accurately calculated. We have our engine coolant temp and our intake air temperatures. Sensors calibrated here, so all that is good. The map pressure sensors also set up, calibrated into the Motec. So all of that has been accounted for, which now allows me to go in and set up my volumetric efficiency values. So the percentage of cylinder filling. Now we've talked about the general values we want to have in our table, and I've populated some of those general values in here to begin. Now my engine is naturally aspirated, so I'm going here from 0 to 110 kPa. 100 kPa is atmospheric, so I went a little bit above that. And then I went here from 0 to 9,000 RPM. I plan on revving this K24 engine that's built up to about 8,500, so I'm giving myself a little bit of leeway in my volumetric efficiency scaling here for the table. Now, I also want to note, if I go in here to ignition tuning, that I have set pretty safe and conservative values in here so that I can populate out and dial in my airflow model. We'll be talking about ignition timing in other training modules, but we do want to have reasonable values in here to start. So I have pretty conservative values here at full throttle, where I'm getting up into the higher load here of something like 15, 16, 17 degrees of timing, and then in part throttle here, 30 degrees. These are all pretty conservative values to get things going. This will give me reasonable throttle response and output out of my engine, but I'm not putting my engine into potentially dangerous conditions. So I have reasonable spark timing values, which now allows me to evaluate my airflow model. Now, I have populated the injector data for RDX 410cc injectors in my injector information, and we know why that's important. Bad data can skew our volumetric efficiency table. So under my injector data here, I have put this information in. This is not a Motec characterized injector, so I've entered in the data that I've collected from doing testing on other vehicles with the RDX 410. So I've populated my latency linearization table, and I've also populated my reference flow and put all this information in. So we should find that when we're calibrating here a volumetric efficiency table, that we're not bringing in any kind of fueling errors or any kind of other errors in terms of our sensor data. Again, we've calibrated everything. We should find what we populate in here should be pretty close. So we have pretty good reasonable VE values in the table here, but now what we're gonna do is utilize the closed loop correction to either make a manual adjustment to our VE values to see if these are correct or not, see how far our airflow model is off by based on the percentage of cylinder filling, or utilize a auto tune type of function, which is called quick Lambda Adjustment, which is built into the software, which is a handy feature. So you can do either or. One is not going to be better than the other. The quick tune feature, quick Lambda Adjustment feature, is going to be a little bit faster at making the adjustments potentially, but you'll have to weigh if you want to use it or not. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.